Welcome to The Explainer. Today, we're breaking down one of the most critical factors in flight safety, visibility. It's not just about how far you can see from the cockpit. It's about really understanding the weather that can turn a beautiful, clear day into a serious challenge, sometimes in a matter of minutes.
So let's start with a question. What do you think is the most common and dangerous weather for pilots flying near the ground? Now, you might be thinking of big things like thunderstorms or turbulence, right? But often it's the quiet, sneaky stuff that clouds your vision that poses the biggest risk.
Here's our flight plan for today. First, we'll cover why visibility is so important. Then, we'll get the big picture of what reduces it before doing a deep dive into the many faces of fog. After that, we'll look at some other culprits, and then wrap it all up with how you, as a pilot, can use this knowledge. And, of course, we'll finish with a quick quiz.
Okay, let's dive right in. So why all this fuss about visibility? Well, before we can talk about what messes with it, we need to be on the same page about what it actually is. There's an official definition that every pilot and controller uses, and it's our starting point.
So, at its heart, visibility is just a fancy way of saying, how clear is the air? It's the answer to a simple question. How far away can I look and still tell what I'm looking at? And that one number, that simple distance, determines everything. Whether you can legally take off, whether you can land, or whether you can fly by looking out the window at all.
All right, let's zoom out a bit for the big picture. When we talk about things that reduce visibility, what are we really talking about? Well, all the different culprits out there basically fall into two main groups. And here they are. You can think of them as falling into two camps. On one side, you have things made of water. Think fog, mist, clouds, and rain. On the other side, you have tiny solid particles floating around, stuff like smoke, pollution, dust, and sand. They can look pretty similar from the cockpit, but how they form and how they behave are totally different. Now, let's get into the nitty-gritty of the most famous visibility reducer of them all, fog. You see, fog isn't just one thing. It's more like a family of different weather phenomena. Knowing which type of fog you're dealing with is absolutely key to predicting what it's going to do next. So, first things first, what's the actual difference between fog and mist? It all comes down to one magic number, 1,000 meters. If you've got water droplets in the air and you can't see a kilometer, it's officially fog. If you can see 1,000 meters or more, it's mist. It's the same stuff, just a different level of intensity. Okay, let's meet the first member of the fog family, and it's the most common one, radiation fog. The easiest way to think about it is this. On a clear night, the ground radiates its heat out into space and gets cold. This cold ground then acts like a refrigerator, chilling the layer of air right above it until, poof, the moisture in that air condenses into a blanket of fog.
Think of radiation fog like a recipe that needs 3 perfect ingredients. First, you need plenty of moisture in the air. Second, you gotta have clear night skies. The clouds act like a blanket, so without them, all the ground's heat can escape. And last, you need a very light wind, just enough to gently stir that cooling air near the surface, but not enough to blow it all away.
Next up is advection fog. Advection sounds complicated, but it just means moving sideways. So picture a big slab of warm, humid air. Maybe it came from over the ocean, drifting horizontally over a much colder surface, like chilly land or a cold ocean current. That cold surface chills the air from the bottom up to its dew point, and you get fog. This kind can be way thicker and stick around a lot longer than radiation fog. Now, there are a few other types you should know about. Frontal fog happens, you guessed it, around weather fronts. Steam fog is what you see when really cold air moves over warm water, making it look like the lake is steaming. And then there's hill fog, which is kind of a funny one. It's not really fog at all. It's just a regular cloud that's so low it's touching the side of a hill or a mountain. All right, we've spent a lot of time on fog, and for good reason. But it's not the only thing out there that can wreck your view from the cockpit. So let's broaden our horizons and look at some of the other common culprits. Okay, this is one of those facts that seems totally backwards until you think about it. You'd assume rain is worse for visibility than drizzle, right? Nope. Drizzle, with its millions of tiny, densely packed droplets, is actually a much bigger problem. With light rain, the drops are bigger but farther apart. You need a serious, heavy downpour before rain really starts to cut down what you can see. But when that precipitation freezes, well, that's a whole different ballgame. Heavy snow can be one of the most dangerous visibility reducers out there. We're talking about true whiteout conditions, where the sky and the ground just merge. The horizon disappears completely. Visibility can drop to just a couple hundred meters, sometimes even less.
And then we have haze. Now remember, unlike fog, haze isn't made of water, it's made of tiny, solid particles. Think smoke from wildfires, pollution from cities, or fine dust. And what makes it even worse is something called an inversion, which acts like a lid on the atmosphere, trapping all those particles near the ground. It can get really bad, especially if you have to fly looking towards the sun.
So we've identified all these different things that can block our view. But how does a pilot actually use this information to make smart decisions? Well, it's all about connecting the dots and understanding the bigger picture of what the atmosphere is doing. This table right here, this is gold. It's basically a pilot's cheat sheet that connects the type of visibility to how stable the air is. Remember, stable air is lazy. It doesn't want to move up or down. That's where you get widespread, layered stuff like radiation fog, drizzle, and haze. Unstable air is the opposite. It loves to move vertically. That creates things like big cumulonimbus clouds and heavy showers, but often with really great visibility in between them. And there's no time where this matters more than on final approach. This is where it gets really tricky. You could be flying along in clear air, and then, as you descend, a thin layer of shallow fog suddenly swallows the runway. Or rain on your windscreen can make the runway lights blur and dance, creating all sorts of illusions. And trying to land while looking into the sun through haze, it can be absolutely blinding.
Okay, you've taken in a lot of information. Let's do a quick review to make sure the most important points have really stuck. Ready? First up, let's see if you remember that crucial number. What's the official dividing line that separates fog from its less intense cousin, mist? That's it, 1,000 meters. It's the internationally agreed upon standard. Less than a kilometer, it's fog. A kilometer or more, it's mist. Simple as that. Okay, next question. Let's think back to our recipe for radiation fog. Do you need strong winds for it to form? True or false?
And the answer is false. Remember, radiation fog needs just a gentle little stir. If the winds are too strong, they'll mix up the air too much, and instead of fog on the ground, you'll just get a low layer of stratus clouds.
And that brings us to our last and most important point. See, this isn't just about being able to name the weather you're currently in. It's about being able to predict the weather you're flying into. By looking at a forecast and understanding if the atmosphere is stable or unstable, you can start to anticipate what kinds of visibility problems you might face. And that's the difference between just flying an airplane and being a truly great pilot.